Okay, for Module 23, we have a bunch of repeat topics again. So, completing the square from Module 6, and then we have distance between 2 points in the plane with exact answers, midpoint of a line segment in the plane, some of your work with finding the center and the radius of circles from Module 8 are all in there. And then rewriting a quadratic function to find its vertex and sketch its graph. That was from doing parabolas in Module 13. So that is one, let's see, 1, 2, 3, 4, 5, 6, 7, almost half of your module here you've already covered. So if you need any help with those, go back to those modules. Otherwise, we're going to start here with solving a quadratic equation by completing the square, which is actually back from chapter 1.4. So it kind of follows from this first guy from module 6 with completing the square. So let's get going with that one. So you know how to solve a quadratic equation using the quadratic formula. This is another method, and a lot of kids really like this method, but just since you're taught the quadratic formula first, that kind of sticks with you. But this is a great one too. So you might decide that you want to try doing this more often. Okay, so if we have a quadratic here, so again, x squared minus 8x plus 2 equals 0. Okay, so we might as well, if you were going to use the quadratic formula to do this, we would do the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, right? And then what you would need to do is simplify this. It'd be 8 plus or minus the square root of 56. I think I did that right. 64 minus 8. Okay. All over 2. Okay. 56, we have to now simplify that radical. So it'd be 8 plus or minus the square root. 4 goes into 56 14 times. So 4 times 14 over 2, which allows us to pull a 2 out of there. And then we can split that up. So it's 8 over 2 plus or minus 2 square root of 14 over 2. So your final answer is 4 plus or minus the square root of 14. Okay, and that would be using the quadratic formula. Now, if you want to complete the square here, so remember, you split the middle term. Okay, and then, I guess, depending on who your Algebra 2 teacher was, what you do here might be a little bit different. What I had my kids do is then we expand that. So that would be x squared minus 8x plus 16 if I did x minus 4 squared. Okay, but we don't want 16, we want 2, which means that I have to subtract 14 from this. So that is equivalent to x squared minus 8x plus 16 minus 14, which would be x squared minus 8x plus 2. Okay, so that would equal 0. Okay, so first step is just completing the square. So if you need to review with that, again, that's module, scroll back up here, in module 6 we did completing the square. Okay, once you have that done, you need to solve for x. So we can add that 14 to the other side. We can square root it. Just make sure that you do positive or negative square root of 14. Since x minus 4 could be the square root of 14, or it could be the negative square root of 14. And then when we square it, we get 14. So x is 4 plus or minus the square root of 14. And that's it. So again, a lot of you, since you're taught the quadratic formula first, you kind of shy away from that method. But look how nice that was without, you don't have to simplify the radical. We didn't have to reduce much there. You know, we can do another one here just to show you. Let's do another one. Okay, so the next example, I'm going to kind of squeeze it in here. We have x squared minus 10x plus 22 equals 0. So if I were to do the quadratic formula, opposite of b plus or minus the square root, x equals that, of b squared minus 4 times a, times c. I'm actually going to get out my calculator. Well, I guess I don't need my calculator for that. Okay, all over 2a. So 10 plus or minus the square root of 100 minus 88, so it'd be 12. So that's 4 times 3. So we'd have 10 plus or minus the square root, or 2 square root of 3 over 2. So that'd be 5 plus or minus the square root of 3. Okay. If I complete the square, x minus 5 squared, and that would give me x squared minus 10x plus 25. So I know I need to subtract a 3. Okay, so then x minus 5 squared, add 3 to both sides, equals 3. X minus 5 is the positive or negative square root of 3. X equals 5 plus minus square root of 3. So much easier if you can do it that way. Okay. All right, we're going to get to our next topic here. Something a little different for you guys. You have not seen this one before, probably, unless you did it in pre-calc. I don't know if you guys do partial fractions in pre-calc. I kind of think you don't, based on what I see my calculus kids come in knowing. Okay, so we have introduction to partial fraction decomposition with distinct linear factors. Okay, so we have an expression like x plus 4 over x times x plus 2. Okay, and we are going to break this up into its linear, or factors, let's see here, 2 fractions that would have linear denominators, which means there's no x squared in them. Okay, so basically what we know is that this can be written as the sum of something over x plus something over x plus 2. Okay, because when you think about it, and we're gonna show that something is an a and a b. Okay, so that's what I mean by we're decomposing this fraction into its parts. So we get that partial fraction decomposition. Okay, and think about it in reverse. If I had something over x plus something over x plus 2, if I wanted to add fractions, I would need a common denominator. So it would be a times x, x plus 2, x times x plus 2, plus b times x over x times x plus 2. Okay, so that when I combine them, I can add my numerators and my denominators x times x plus 2. Okay, and that numerator would be whatever a times x plus 2 plus b times x is. Okay, we're just kind of taking this in reverse. We're given everything together, and we want to break it down to these guys. Okay, so I'm going to switch colors here a little bit. Again, and I'll do 2 examples like this. Okay, so we are given this. So we take a look, we split it into the 2 factors of the denominator. So an x and an x plus 2, and we get this. Okay, now the next thing we do is we multiply everything by that first denominator. Multiply everything by x times x plus 2. Okay, so we're gonna have x plus 4 over x times x plus 2 times x times x plus 2 plus equals a over x times x plus 2 plus b over x plus 2 times x plus 2. Now what that does then is it clears all your denominators. Okay, the x's cancel out, the x plus 2's cancel out, the x's cancel out, the x plus 2's cancel out. All right, now that leaves you with x plus 4 equals a times x plus 2 plus b times x. Okay, so now we need to figure out what a and b are. Okay, and this statement that I just wrote in purple, it has to be true no matter what x is. Okay, that has to be a true statement. So I can strategically pick some x's that will help me solve for a and b. So for example, if I were to make x equal -2, okay, then what's going to happen is when I plug -2 in on this a term here, it's going to be a times 0, which is 0. Okay, so I'm going to have -2 plus 4 equals a times -2 plus 2 plus b times -2. So I get 2 plus -2b. Okay, so then I get 2 equals 0 minus 2b. Okay, so 2 equals -2b. Divide both sides by -2. Okay, and then -1 has to equal b. Okay, and then what I can do is strategically pick x to equal 0, which will help me get rid of that term, the bx term. Okay, so then I'd have 0 plus 4 equals a times 0 plus 2 plus b times 0. So 4 is 2a plus 0. So a must be 2. Okay, so what I end up with is my answer is this, but now I know what a and b are. Okay, a is 2, so 2 over x plus b is -1, -1 over x plus 2. And there's my solution. Okay, I'm going to do another one for you here. A little bit more abbreviated work so you can get the process a little quicker. Okay, my next one, I have 2x minus 4 over x plus 1 times x plus 3. So I'm going to immediately split that up. A over x plus 1 plus b over x plus 3. Okay. Now I take everything and multiply it by x plus 1 times x plus 3. So left-hand side will be 2x minus 4. In my a term, the x plus 1's cancel out. In my b part there, the x plus 3's cancel out. Okay. So now I can tell I'm going to make x equal -3, and then I'm going to make x equal -1. So if x is -3, 2 times -3 minus 4 equals a times 0 plus b times -3 plus 1. So -6 minus 4 is going to equal -2b. So -10 is -2b. So that makes b 5. Okay, and then when x is -1, I'm going to have 2 times -1 minus 4 equals a times -1 plus 3 plus b times -1 plus 1. So -2 minus 4 equals a times 2 plus 0. So -6 equals 2a. So a is -3. Okay, so my answer then is going to be -3 over x plus 1 plus 5 over x plus 3. Our next one, okay, the only difference between what we just did and the next one is that in the next one you have to factor the denominator. So this one, it came factored for you. This one came factored for you. So our next step, we just have to factor it ourselves. Okay, so the next one is partial fraction decomposition, just not the introduction. With distinct linear factors. Okay, so I'll just do one of these because, like I said, the only additional step here, factor the denominator yourself. Okay, so if I have -3x minus 4 over x squared minus 2x. Okay, numerator is going to stay the same. Denominator, I can factor an x out, and I'm left with x minus 2. And then that's it. Everything else is the same. So a over x plus b over x minus 2. Okay, so we'll go through and multiply everything by x times x minus 2. Okay, so I'll have negative 3x minus 4 equals a times x minus 2 plus b x. If x is 2, I have negative 3 times 2 minus 4 equals 0 plus 2b. So negative 6 minus 4, negative 10 equals 2b. So b is negative 5. Okay, and then if x is 0, negative 3 times 0 minus 4 equals a times 0 minus 2 plus 0. So negative 4 equals negative 2a, and a then is 2. Okay, so my answer, I solved for a and b, 2 over x plus negative 5 over x minus 2. Okay. All right, what do we got next here? We have graphically solving a system of linear and quadratic equations. So previously in the previous module, you did solving a system of linear equations. Now we're going to have one line and one parabola. Okay, so graphically solving a system of linear and quadratic equations. Okay, so graph the system and then write its solution. So we have y equals 2x squared minus 4, and y equals negative 2x. Okay, so we're going to graph the parabola. So there's a lot of different ways you can graph the parabola, but finding points on it is probably going to work just fine for this. Okay, so and the fact that you're solving it graphically means that the numbers are going to be nice. Okay, so we're not going to do anything too crazy here. But in our parabola, if x is, the easiest thing to start with is 0, then y is negative 4. So we can do, oh, you know what? I'm going to do my background here as a grid. There we go. Okay, so then I can do this a little bit better. Okay. So on my parabola, I have 0, negative 4. Okay. And then if x is 1, then I'd have 2 minus 4, which is negative 2. And if x is negative 1, I'd also have negative 2. Okay. If x is 2, let's say 2 squared is 4, times 2 is 8, 8 minus 4 is 4. So 2, 4, and negative 2, 4. Okay, so we'll stop there for now. There's my parabola. I'll use a different color for the line. Let's use this blue. Okay, y equals negative 2x, so 0, 0 would be the intercept. Slope is negative 2. So there we got one of them. And there's the other one, right? There's our two spots where the line will intersect the parabola. So our answers are 1, negative 2, and then we have negative 2, 4. Okay, so just take your time to graph them right, and they should definitely intersect at some nice points for you since you're not using a calculator for this at all. Okay. Moving on, we only have 4 left here. Writing a system of linear equations given its graph. Okay, so writing a system of linear equations given its graph. So it's really, go back to 8th grade math, 7th grade math, where you looked at the graph of a line and you gave it an equation for it, and you're just doing that twice here. Okay. So if, for example, we have our first line.
Harrison Mueller, you have an item at the security desk for pickup. Harrison Mueller, please stop by the security desk.
They kind of highlight a couple points for you on the line. Okay, so there's the first line, and then our second line also goes through this point, and it also goes through here. Okay. Okay, so when you do this one, you'll see the lines, they actually show you the points as these big red dots. Okay, and again, that's all you have to do now is find the equation of the two lines. Okay, so for the blue line, y equals our slope there, rise over run, right? So this is at up 1, 2, 3, 4, 5, 6, and then over 2. Rise over run, so 6 over 2, which is going to be 3. So 3x plus the y-intercept there at 2. And then for our green line, y equals, the slope would be down 1 over 2, so negative 1/2 x, and our y-intercept is negative 5. And that's it. That's your solution. You're just writing the equation of the two lines. Okay, next one. Hold on, lost my spot here. Okay, creating an inconsistent system of linear equations. So remember, an inconsistent system has no solution. Okay, so creating an inconsistent system of linear equations, we're coming up with two lines that don't intersect. Okay, so they give you something like 10x plus 15y equals 11. Okay, and then negative 8x plus cy equals 10. All right, so this is an interesting problem. What you want to do here, and let me just check, let me figure out how they want you to do this. Okay, so if you remember, when you do the elimination method, you multiply one of the equations by a constant so that things will cancel out. Okay, so what we want to do here is we want to get everything to cancel out. I'm just trying to think here how they want you to do it. Okay, so what are they doing here? Okay. I think the easiest way to do this is to figure out how you can get these to have the same slope. Okay, so we're going to rewrite these in slope-intercept form. So we're going to have 15y equals 11 minus 10x. So y is 11 over 15 minus 10 over 15x. Okay, and you can tell that's always going to be like that. All right, it's always going to be the opposite of the coefficient on the x over the coefficient on the y. Okay, so we can also see that with this guy, where cy will equal 10 plus 8x. So y equals 10 over c plus 8 over cx. Okay, so again, the slopes are negative coefficient of x over coefficient of y. Okay, and we just want those to be the same. Okay, if they have the same slope, then they're parallel lines. Okay, so we just want negative 10 over 15 to equal positive 8 over c. Okay, so we just cross multiply. Negative 10c is going to be 8 times 15. Negative 10c is going to be 120. Right, 8 times 15. 8 times 10 is 80. 8 times 5 is 40. Add them up, we get 120. So that means c has to be negative 12. Okay, and that's it. Okay, it does not have a solution if c is negative 12. Okay, I'll do another one like that for you. That's kind of an interesting one. That at first it looks really difficult, but then if you think about it, it's not too bad. Okay, so our next one, we have bx minus 8y equals 11, and negative 9x, that's a bad I, plus 12y equals 17. Okay, so the slope on this one, again, negative coefficient of the x over the coefficient of the y. Okay, so we'd have negative b over negative 8, which is just be b over 8. Okay, and then this one, the slope, again, negative coefficient of the x, which would be 9, over the coefficient of the y, which is 12. Okay, so we set those equal to each other. B over 8 equals 9 over 12. If you want to, you can reduce 9 twelfths, divide by 3, and you get 3 fourths. Just makes it a little smaller numbers to work with. So 4b equals 24, which means b equals 6. Okay, and that's it. All right, 2 more. Your next one is consistency and independence of a system of linear equations. Okay, so in this one, they're going to find two numbers, a and b, such that the following system of linear equations is inconsistent. Okay, so what that means, again, that it has no solutions. Okay, but that also means, okay, all right, they can't have, so one thing I kind of like glossed over up here is that they have to have the same slope, but they can't have the same y-intercept, and I think they have these all set up such that they wouldn't. So they have to have the same slope, but not the same y-intercept. Okay, so if we go back here, these are kind of throwing me off. I haven't done problems like this in a while. Let's see here. An example here, we have 2x minus 4y equals negative 3, and we have ax plus 5y equals b. So again, if we get these in slope-intercept form, actually, let me give myself some more room here. Okay. If I have 2x minus 4y equals negative 3, then that'd be negative 4y equals negative 3 minus 2x. So I can divide everything by negatives. So let's get rid of all those negatives. So y would be 3/4 plus 2/4 x. okay, which I'm going to simplify it. But notice that the slope is 2/4, okay? And again, that's negative coefficient of x over coefficient of y, okay? And my y-intercept is 3/4, and that's always going to be that constant term over, let's see here, the coefficient of y. Okay, so another way that you can think about this too is if this is the form, right to the side here, ax plus by equals c, your slope is negative a over b, and your y-intercept is c over b. Okay, and that's what we see in that yellow one. All right, we're going to do the other one and show you that it works out to be the same. So, actually, we're not going to really be able to do that because that one's got the unknowns in it. Okay, but the slope of this one would be negative a over b, so negative a over 5. And our y-intercept is going to be c over b, so b over 5. Okay, because in this, I know it's confusing because we have lowercase a's and b's and everything, but in this one, a is a, 5 is b, and b is c. Okay, so in order for it to be inconsistent, same slope, not the same y-intercept. So we want 2/4 or 1/2 to equal negative a over 5. So 5 will equal negative 2a. So a will equal negative 5/2. Okay, so there's part of it. And then what we do next is the y-intercept, so 3/4 over here, cannot equal b over 5. Okay, so 15 can't equal 4b. So 15 over 4 can't equal b. So when you put an answer in here, b can be anything you want except for 15/4. Okay, so you could put an answer, a is negative 5 over 2, you write b is 3. Okay, whatever you want, as long as it's not 15 over 4. All right, I'm going to do another one of those for you, a little bit quicker. Let's see, I like all my colors. Okay, ax minus 5y equals negative 6, and 3x plus 2y equals b. Okay, so our slopes, again, the opposite of a over b. So negative a over negative 5 has to equal negative 3 over 2. Okay. If we get rid of those, we can cross multiply. So 2a equals negative 15. So a is negative 15 over 2. Okay. And then, this one said something different. Oh, okay. Read the directions carefully. Okay. This one said consistent. Consistent. I'm sorry, this one said inconsistent. I believe it did. Okay. So same slope, not the same y-intercept. This example now is asking for something that's consistent, dependent. So that's the same slope and the same y-intercept. Okay, I'll summarize this below again and maybe even do another one. Okay. Your y-intercepts then, I remember C over B up there. Okay. So we're going to have -6 over -5 has to equal B over 2. Okay. So we're going to get those positive. So 2 times 6 would be 12. That's a 6, not a B. Equals 5B. So B is 12/5. Okay. And that's your answer there. All right, so let me summarize again. Okay. I'll use this green again. So when we have AX plus BY equals C, the slope is negative A over B. Okay. Your y-intercept is C over B. I'm double checking up there. Okay. If they are what we call consistent dependent, they have to have the same slope and the same y-intercept. They're the same line. Okay. If they are what we call, let me just get the terminology that they use here, inconsistent. They're going to have the same slope and a different y-intercept. Okay. And if they are they going to have you consistent independent? Let me see. Consistent dependent. I don't think they're going to give you any consistent independent. Okay. So that's it. So that's what you have to do. Okay, so set up the slope, set up the y-intercepts. It's always going to be that cross multiplying there. Okay. All right. Our last one. Solving a word problem using a 3x3 system of linear equations, problem type 2. So we have done 3x3 systems already. Excuse me, I need some water. We've done 2x2 word problems, so now we're doing 3x3 word problems. Okay, they can be a little bit overwhelming, so if you need help setting them up, just let me know. We have, in this example, the Cook family takes their clothes to the local cleaners. The table below gives the number of coats, shirts, and dresses they had cleaned over the course of 3 months, and they had no other items cleaned there. So our table looks like this. Number cleaned. And they have January, February, March. And they have coats, shirts, and dresses. And we've got 5, 9, 8, 8, 8, 4, 4, 7, 5. Okay. Says that they spent $57 in January, $89 in February, and $68 in March. And they want to know how much does it cost for each item. Okay, so if you remember with our word problems, what we want to do first is figure out what your answer needs to look like. Okay, the cost for each item. So X will be the cost of coats. Y will be the cost of shirts. And Z will be the cost of dresses. okay? And then our rows are going to give us our total, okay? Total in January, total in February, total in March. So in January, we will have 5x plus 8y plus 4z needs to come to $57. In February, 9x plus 8y plus 7z comes to $89. And in March, 8x plus 4y plus 5z equals $68. Okay, I'm pretty sure you're going to be able to use your calculator for this, but remember, we want to figure out what variable we can eliminate. Okay, in this example, I'm looking at the y's, and those look really good because I've got 2 8s there. So those will cancel each other out through subtraction. And then with that 4, all I need to do is double it. Okay, so I'm going to do January minus February. Okay, so 5x plus 8y plus 4z equals 57. Actually, I'm going to do February minus January so I can have the bigger numbers on top. So 9x plus 8y plus 7z equals 89. So I'll subtract those, and I get 4x plus 0 plus 3z equals 32. Okay? Now I'm going to double March. So I'd have 16x plus 8y plus 10z equals 136. Okay? So I'm going to take that guy and do 2 March minus, doesn't really matter. Let's do February. 2 March minus February. Okay? So then I've got 9x plus 8y plus 7z equals 89. And subtract, so I get 7x, 0y, 3z equals 136 minus 89, 47. Okay, and that worked out super well because now I can get the difference between these two, and it's already set up where the z's will cancel out. So 7x plus 3z equals 47. 4x plus 3z equals 32. Subtract, so 3x equals 15. So x is 5. So the cost of a coat, $5. Okay, plug it back into whatever I want. 4x, so 4 times 5 plus 3 times z is 32. So 20 plus 3z is 32. So 3z is 12, which makes z 4. Okay, so the cost of dress is $4. And now I can go back to one of my originals. So I'm going to do that down here. Sorry, it's getting a little messy. 5 times x plus 8 times y plus 4 times z equals 57. So 25 plus 8y plus 16 is 57. So that's going to be 41 plus 8y is 57. 57 minus 41 is 16. So y is 2. So a shirt is $2. Okay? And then remember, I could plug it back in. If I want to check my answer, I could plug these back into any of those equations. And not January, because I already used January, but plug it into February or March and make sure you get the right answer. Okay? I think that's it for that module then. Yep, we're all done. Okay?